these are our solutions for our review packet. I believe these are the green pages. We're going to do 11 through 20 in this video, and just as a spoiler alert, you can skip number 20. So if you've been struggling with 20, you can skip that one. So this problem, the In My Chevrolet, and the next problem have to do with the normal curve, and most specifically, I gave you some guidance on this in the overview for Unit 2 and 3. And I had you write this information on the back of the overview. So this is the front of the overview. And what you are doing in these problems is this bottom part. You convert an x value to its z-score and then find the area under the curve. What may be more helpful to you, though, is what I had you add onto the back of this overview, and then I have a page number here if you numbered your page numbers like my page numbers. So the first problem is this. You know mu and sigma, and they ask you about a percent or a probability or proportion of x. So we use the mu, the sigma, and the x that they give us to find z. Then we look up that z-score on the purple table and find the area under the curve. So this little graphic here is just saying use these three numbers to find z, then find area under the curve. Part B is this. You need to use the area under the curve to find z, and once you know z, you use its equation to solve for x, mu, or theta. So this is how you solve page 11 and page 12. Please really give it a try before you keep going with this video. So pause and then come back when you've done it. Okay, so for part, the first one, there's not a part, In My Chevrolet, this says for n is 1120. I don't know why I have that written there. The Chevrolet Malibu with a 4-cylinder engine has a combined gas mileage of 25. What is the percent of all vehicles? What percent of all vehicles have gas mileage worse than the Malibu? There are okay, so this is the data set without the outliers. Sorry to waste your time. I just got worried about that. So this is for data without the outliers. So for the sample size of 1120, we have a normally distributed set of data with a mean of 18.7 and a sigma of 4.3. All of the things that I have for this problem are required for an E. If you're missing any of them, they'll give you a P. So if you're missing naming your normal curve, it's a P, which is painful because you know how to do it. We just left off one little thing. So here, this is x is 25, which matches a z-score of negative 319. That does not make sense. It looks like maybe I did it wrong the first time and then changed it. Pause. Let me see what I have going on here. Sorry, guys. Okay, it looks like I just made a mistake and didn't fix my normal curve. I should have noticed this when I did it wrong the first time, but for this normal curve, 18.7 is in the middle. So a z-score of 0 matches the mean of 18.7. So that means my flag should have been over here because this is x is 25. So 25 should have been to the right of the center, not to the left. So this flag is wrong. Then this matches a z-score of 1.46. which lines up to an area of 92.79. So I also should have recognized that this little area I had shaded in was not 92% of the data. So this is showing my AP grader that I know that 92.79% of my data is to the left of this little flag that I have drawn here. Notice that I'm saying in order to find the percent that's less than 25, I need to find the percent that is less than a z-score of 1.46, which is 92.7. So I want to reiterate one more time that you cannot leave off anything here and still get an E, still get full credit. Okay, for the top 10%, we work backwards. So I want you to notice a little bit how my picture is different. So this time, I do not know X. And what they gave me was A. They told me that the area to the right is 10%. But my table only gives me the area to the left. Our purple table only gives us areas to the left. So what I look up in my table is 0.90, the z-score that's closest to 0.9000. That is a z-score of 1.28. So I had to find this z-score. So I used the area that they gave me to find the matching z-score, and then I use that to find X. Notice I have labeled my normal curve once again. The equation then is 1.28 equals X minus the mean divided by the standard deviation. To solve this, you would multiply both sides by 4.3. So if I multiply by 4.3 here and 4.3 here, these go away and I get X minus 18.7 equals 5.504. Then to know what X is, I just need to add over this 18.7. So you're going to add 18.7 to both sides, and that gives you an X of 24.204, and you want to answer this with context. Same as I did up here. I didn't just write 9279, I finished with about 92.79% of all vehicles have worse gas mileage than the Malibu. Down here, in order to fall in the top 10% of all vehicles, a vehicle's gas mileage must be at least 24,204. So for these, you want to make sure that you feel good about these problems because you'll for sure have one in your free response. I'm confident that you will have a problem that requires you to draw the normal curve and make a statement. So question 12 then is the same setup as page 12 is the same setup as page 11. So part 1 is asking you to use X, sigma, and the mean to find a percent, and then B is asking you to find a z-score and then solve for the missing information. So pause if you haven't done it yet, follow this problem, use this problem as your guide. Okay, I'm going to show solutions for part A. So normal curve is labeled. The X and Z value on my normal curve is labeled. The area that I'm finding is shaded in. I'm clearly showing my z-score calculation. You do need to say z equals. If I want to know the percent of seeds that weigh more than 500, I need to find the percent of data that is greater than a z of negative 0.23. Well, our Z table does not give us areas to the right. It only gives us areas to the left, so we need to do 1 minus this area. So that gives us 0.591. About 59.1% of seeds weigh more than 500 milligrams. You need to have everything for an E. Then if you discard the lightest 10%, what is the smallest weight? So in this case, the lightest 10% means the 10th percentile. So you are trying to find the Z-score that has 10% to the left of it. So you look inside the table for the value closest to 0.1000. That's a Z of negative 1.28. I have this drawn as a picture right here. So I'm showing that I know a Z-score of negative 128 has 10% of the data to the left. I am looking for what X is. So just like in the last problem, I'm going to plug it into the Z formula and solve. So first, multiply both sides by 110, then add over 525. The smallest weight among the remaining seeds is about 384.2. Okay, the next few problems are on scatter plots. So the best advice that I can give you for this problem is to go to your scatter plots tab and find the things that you need. So if you need to describe a scatter plot, you would use the page that says describe. If you need to do the regression line, that's this page, page 409. If you need to find a residual, that's page 413. If you need R squared and S, that's page 417. So scatter plots is a unit that I personally think is pretty easy to find what you need. So this is all in scatter plots. So give the equation for the least squares line, define any variable that you use. Is a linear model appropriate for this data? Anytime they ask you if a linear model is appropriate, they are always wanting you to talk about the residual plot. Memorize that, make a flashcard of it if you need to, but anytime it's asking if a linear model is appropriate, you must refer to your residual plot. And then interpret values of R squared and S. So the line is given up here. The number that is across from the constant is your A value. Then right underneath the word constant, it'll have context. It'll match what the explanatory variable is. So notice on the graph, the X variable is called cone index, and on the table, it is also called cone index. This is your slope. So down here, I have that y hat equals 1.4146 plus 0.4399x, where x is the cone index and y hat is predicted number of offspring. You need everything for an E. If you leave off the word predicted, no credit. Is a linear model appropriate? Yes, a linear model is appropriate for this data because there is no leftover pattern in the provided residual plot. Also, correlation is 0.756. So you find correlation by taking the root of R squared. This is R squared right here, 57.2. So you change that to a decimal, and that gives you your R value. So R is 0.756, which indicates a moderately strong positive linear association between cone index and number of offspring. E is both. You mentioned residual plot and R. P is residual plot. I would be just using R, or R squared. C, this is R squared. So this is R squared. About 57.2% of the variation in average number of offspring per female over 16 years is explained by the cone index when using the least squares regression line. Then up here next to the graph, because I ran out of room, is S. Our predictions will typically be off by about 0.6 offspring from the actual number of offspring when we use the LSRL. (14) is another scatter plot. So they give us the graph, the residual, let me be more clear. They give us the scatter plot, the residual plot, and the computer output. They want us to write their regression line and then use SR squared and the residual plot to tell, or what does those things tell you about the regression model. Okay, S is right here, it's labeled S. R squared is right here. Remember, constant is always your A, and then the word that matches what's on your x-axis is always your slope value. So there's the equation for the line, where x is pre-test score and y hat is predicted post-test score. A linear model is appropriate because the residual plot does not show any leftover patterns. So what does this tell you about our linear regression model? A linear model is appropriate. 55.8% of the variation in post-test score can be explained by the pre-test score when using the least squares regression line. And our predictions will typically be off by about 12.55 points when using the LSRL. So I actually should have added in there, our predictions will typically be off by about 12.55 points from the actual score when using the LSRL. So our predictions will be 12.55 points from the actual score when using the LSRL. Okay, this one, which one of these funds has a closer relationship to the returns from the stock market? So remember, closer relationship means which one of these will have points that is closest to the regression line. So if I go into scatter plots and I look at my first set of notes about describing scatter plots, I want you to notice the difference between a strong relationship and a weak relationship. So if the points are far away from the regression line, your R is going to be small. And if the points are very close to the regression line, then your R is going to be large. So keep in mind here, this is a really good picture, that this would be considered a close relationship. Look how high your R is. This would be considered a weak relationship. Notice that the points are farther away, and look at the value of this R. So you want to use the values of R given to you in the prompt to decide which has a closer relationship. And then B, does this information tell us anything about which funds have the higher returns? A, you should be able to answer. B, I understand if you need to see the solution on that one. So, A, Fidelity Tech Fund has a closer relationship to returns from the stock market because its correlation of 0.77 is stronger or greater than the correlation of 0.37 for the Fidelity Real Estate Fund. So you don't even need to say that these points will be closer to the regression line than these points will. You just need to clearly state that it's Fidelity Tech Fund because the correlation is higher for the Fidelity Tech Fund than for the Real Estate Fund. Then B, correlation describes the strength and direction of a linear relationship. Correlation does not give us information about the values of the variables, so the information given will not tell Joe anything about which fund has higher returns. We would need to know more than just the correlation to know which fund is giving higher returns. Okay, page 16 is another scatter plot problem. So 1, they want you to make the scatter plot. 2, they want you to find the least squares regression line. And to remind you what that is, it's stat, calc, option 8, which is linear regression. C, it wants you to use the regression line from part B to predict a height. And D, do you expect your prediction to be accurate? Give evidence to support your answer. So your prediction is more accurate when your points are close to the regression line. And you know if points are close to the regression line because of your R value. So you probably don't want to mention R in part D. Please pause and do this problem if you have not already. Part A, describe what you see in the scatter plot. So my scatter plot looks horrible. It definitely looks like a weak relationship. But I was a little bit nervous to say it was a weak relationship, but I just had to trust myself and move forward with that. Because I was so nervous about this graph and because I had to enter in the data anyways to run my regression for part B, I actually graphed this. So to get a better picture of what it looked like, I graphed it in my calculator. And this is what it looks like on my calculator, which looks so much better than the graph that I have here. And it made me feel a little bit better about the weak relationship because these points here are really going to mess up your correlation. So not only do I have to make the graph, but then I need to state there is a weak positive linear association between brother's height and sister's height. In general, as brother's height increases, sister's height also increases. So A, make the scatter plot, and then describe the scatter plot. B, you need to enter in the data to your lists. You need to go to Stat, Calc, 8, and run the regression for list 1 and list 2. So doing that, you get an equation of y hat equals 27.6 plus 0.53x. They want us to interpret slope. So I found the line. I wonder if I would be dock points because I didn't say where x is brother's height and y hat is predicted sister's height. We may want to add that in. I think that would sound better as predicted height of sister. This is something that if I had time at the end, I would probably just run through my answers quickly, and I probably would have added it in just like this. For every 1 inch increase in brother's height, the least squares regression line predicts sister's height will increase by about 0.53 inches. You need context, you need units, and you need to be very clear that X is increasing by 1 inch. Okay, C, I have Tanya's height to be about 64.7 inches. I wanted to give a written response because I feel like that's what they want a lot of the time. And then last, since the correlation is weak, so when we run that regression, this is your y-intercept, this is your slope, this is your correlation. That is weak correlation. So since the correlation is weak, predicted height will not be very accurate. I don't expect predicted height to be close to the actual height. Why? Because the points are going to be so far away from your regression line. So when the points are far away, that means that your relationship and your predictions are not your relationship is not close and your predictions are not going to be great. Okay, page 17, another scatter plot problem. Interpret the meaning of the slope and y-intercept. So you have a page on that in the scatter plots unit. The student that reported reading 17 books for pleasure had a low GPA. Find the student's residual and interpret it. How strong is the relationship between English grades and number of books? Give appropriate evidence. Whenever they ask about strength, you want to find R. So up here they give you the line. It's not very obvious, but this is predicted GPA is equal to 3.42 plus 0.024 books read, and they give you R squared. So you have to use that information to solve these problems. I'm going to head into the solutions now. A, slope is 0.024. You want to do it like this. So you want to say slope equals and then underneath the interpretation. So slope equals underneath interpretation. For every 1 book read, the LSRL predicts GPA will increase by about 0.024. Y-intercept is 3.42. When books read is 0, the LSRL predicts GPA will be about 3.42. For the residual of the student who read 17 books, his X is 17, his Y is 2.85, his predicted GPA was 3.828. That's much higher than his actual GPA. Residual is almost a full per grade point. Like, that's a lot. This student's actual GPA is 0.978 less than predicted or expected based on the number of books read. Then last, in order to answer this question, I need to know R. They gave me R squared. It's already written as a decimal, so I'm just going to plug that into the root. This gives us an R value of 0.289, which is horrible. The correlation between English grades and GPA is 0.289, so the linear relationship is weak. You could have used the scatter plot to answer. You could have used R squared to answer. So if you wanted to use the scatter plot, you would say the relationship, the scatter plot shows a relationship that is weak. Remember, if you draw the oval around your points, if it's a wide oval, then that means your relationship is weak. If it's like a skinny, flat, narrow oval, then that means your relationship is strong. So drawing the oval, I can see that this is a weak relationship. I can also see that the points are pretty far away from the prediction line, so that also indicates this is not a strong relationship. If you wanted to use R-squared, you could say, I don't think the relationship is very strong because only 8% of the variation in GPA is explained by books read. So you don't have to just use R here. You could use the scatter plot or the R-squared. I think I might have just said you don't need to use the R-squared here. You don't need to use R there. You can use scatter plot or R-squared. Okay, this guy was a doozy. So they want you to construct a plot that displays the distribution of the number of accidents effectively. I decided to use a histogram because of the data that they gave me. So before we get into this problem is pretty complicated and probably very accurate to what you will see on the free response from your actual exam. So because of the way they gave me the data, I decided to make a histogram of this data. So I made a histogram, then it says construct a plot that shows the relationship. If they're asking you to show a relationship and the variables are quantitative, they're asking you to make a scatter plot. So here I did a histogram, here I did a scatter plot, and then this one, D is easier than A, I believe. Okay, so I'm going to move forward to my responses. So A. This was the scatter plot that I got first. I decided to make my bin size 5 and include the accidents within those hours. So you can see that this was my first bin size. I went 1, 2, 3, 4, 1, 2, 3, 4. Shouldn't that be 5? Oh my heavens, did I mess up my very first one? I think I included midnight into the first 5 hours. So I think that I added 2 into this. I'm not 100% sure now that I'm looking at it though. 38, 48, 56, 61. So this really should have been 63. So I should have included this 2, this midnight, and then 1, 2, 3, 4 to get 63 instead of 61. And then I did 1, 2, 3, 4, 5. That was 62 between the hours of 5 and 10. 1, 2, 3, 4, 5. That was 49. 1, 2, 3, 4, 5. That was 15. 1, 2, 3, 4, 5. 75. So did I do that? No, I didn't. I did not need to add that in. I apologize. So 61 is accurate. Sorry. Okay, so then over here, this is the scatter plot that matches this, and that to me looks horrible. I do not. So then I decided, well, maybe I need to make smaller bins. So down here, I have a bin size of 3. So I changed my bin size from 5 to 3. And if I'm remembering correctly, I played around with this a lot in my calculator to see if I could make a nice looking graph. So I'm just going to check really quick to see if this data is still in here. It is not. I used my calculator to graph this and try to find a histogram that looked really good. I think I tried bin size 3, bin size 4, bin size 5, bin size 10, and this is the one that looked the best. So it says make an appropriate plot, so there's my histogram. This is my scatter plot. And as I was graphing the scatter plot, I could see that this was going up, then down, up, then down, up, then down, like a roller coaster. Notice that in all of the plots that I graphed, I scaled and labeled my axes. That's super important. So what does C tell you that, what does the histogram tell you that the scatter plot doesn't? Well, the solution to this says that the histogram is skewed right. I don't really feel good about saying that it's skewed right, but I can see how, I guess I can see how they're thinking that, like maybe they're doing like this kind of a situation, which, yeah, I guess it's skewed right, but this was not obvious to me. It being skewed right was not obvious to me. D, what does this plot tell us that the histogram doesn't? Well, the scatter plot shows that the distribution has 3 peaks, and it could be that there are 3 shifts. If that's the case, there is a peak of accidents at the middle of each shift. So that's how I described my answer for B. This could mean that there are 3 different shifts throughout the day, and the most accidents happen in the middle of a shift. Then there was one more problem we needed to do on this, which says plant managers are concerned that the number of accidents may be significantly higher for the midnight shift than for the 4 to midnight shift. So the early morning shift as opposed to the later shift. So to answer that question, I made 2 box plots. So I made a box plot for the midnight to 8 a.m. shift, and I made a box plot for the 4 p.m. to midnight shift. So these are those box plots. Here are the numbers that I have for the first shift. Here are the numbers that I have for the second shift. Notice they're each 8 because there's 8 hours in each shift. Here are my box plots. And my response is the box plots above show that every statistic in the 5-number summary is greater for the midnight to 8 shift than for the 4 to midnight shift. So the minimum is greater for shift 1. Quartile 1 is greater for shift 1. The median is greater for shift 1. Q3 is greater for shift 1. And the max is greater for shift 1. Although the IQR for the third shift is greater than the first shift, so this box is bigger, the median for the first shift is greater than for the third. Based on the medians, I would tell the plant managers that the first shift typically has more accidents than the last shift. That one is complicated, and I'm hoping being able to see it in these practice problems will help you be prepared for something like this on the actual exam. So for this problem, we had to make a histogram, we had to make a scatter plot, and we had to make double box plots and compare them. That's quite a bit. You want to feel very comfortable with this problem. And then the last one that we're supposed to go through is 20, but we're allowed to skip it. Hallelujah. So we're going to skip it. And I will see you in the solutions to the next 10 pages.